My name is Dante and I'm in my second semester of my major, which is international business. However, I really love to learn new things about astronomy and cosmology. Fun fact, I wanted to study astrophysics, but I ended up in business. So, what are we going to learn today? Well, I'm going to explain the geology of Mars. So, let's begin, shall we? Okay, so what is Mars? Mars is the fourth planet in our solar system. This means that it's after Earth. And according to NASA, Mars is a dusty, cold desert with a very thin atmosphere around it. Before we dive into the geology of the red planet, let's talk a little bit about the history and explorations which have led to the understanding of the geology of Mars. So, Mars is a very interesting planet for most of the people, and most of them want to know how it works. Why does it have that characteristics, or why does it have a very thin atmosphere? But why? Why do people want to know about Mars? Well, this has to do with the fact that Mars could actually be the first planet in which we as humans could actually put a base in another planet. So this is why many scientists focus their work on knowing how this place works and how could we use it to expand our horizons. Approximately, we've sent around 50 spacecrafts to the planet, but the problem is that only half of them have actually reached the planet. The first spacecraft to visit Mars was US Mariner 4, and it flew past Mars in 1965. Now, Mariner 4 had different equipment attached to it, some of which was TV cameras, magnetometers, and cosmic ray telescopes. Mariner 4 accomplished the task of sending 22 photos back to Earth, and scientists for the first time could actually see how was the surface of Mars. They realized that the surface of Mars was like a moon because it had a lot of craters, and they also estimated the atmospheric pressure and the daytime temperature and concluded that Mars had a very thin atmosphere. The first spacecraft that could actually orbit Mars was NASA's Mariner 9 in 1971. This was a breakthrough, as NASA's Mariner 9 was the first spacecraft that could actually map the entire surface of the planet. And what did scientists find? Well, they found volcanoes, canyons, some complex layers in the polar caps, and some channels. During 1976, Viking 1 and Viking 2 were in development, and each one had a lander and an orbiter. The Viking 1 lander arrived to Mars in a place called Chryse Planitia on the 20th of July, and 2 months later arrived the Viking 2 lander in a northern part of the planet called Utopia. The landers carried out experiments to know if there was life on the planet, and they also photographed the planet, while the orbiters gave a more general perspective of how was the geology of the planet. After Viking 1 and Viking 2, there were developed other 2 spacecrafts. The problem is that they never reached the planet, so it was a complete failure. And there were no more explorations until the decade of 1990. It was in 1997 when the spacecraft Pathfinder landed on the planet, and it was the first ever robotic rover to be powered by solar energy. Now, what did Pathfinder found? Well, it measured the temperature fluctuations and also examined some of the rocks and minerals that were found on the surface of the planet. Then, Mars Global Surveyor was the first spacecraft to photograph the entire surface of the planet. So with this, we could create maps of Mars. Next explorations happened in 2003 with NASA's Mars Odyssey and ESA's Mars Express, both orbiters, and both discovered that there was hydrogen in the subsurface. In the same year, 2 Martian Explorer rovers, which were called Spirit and Opportunity, were the first ones to travel around 50 kilometers through the entire surface. They continued the operation on the following years, and Opportunity was able to explore a crater called Victoria. However, Spirit became a fixed station because one of his wheels lost power and he couldn't move as sand trapped him on the surface. The most largest, famous, and most expensive mission happened in 2011 with a rover called Curiosity. The aim of Curiosity was to explore if the Martian surface was a place where life was able to occur. Curiosity landed on Gale Crater in 2012 and it took photographs of gravel found there. Now, the fact that there was gravel there could mean that there could have been water that carried that gravel into that crater. The most recent mission happened in 2018 with NASA's InSight, which right now is analyzing the inner structure and composition of the red planet. All of these missions have given scientists the proper data and information about the red planet so that we can know what the surface of the planet looks like. Now, let's begin with the properties of the Martian surface. First of all, Mars is a terrestrial planet that has almost half of the size of Earth, with a diameter of 6,790 kilometers. Its surface is close to the amount of dry land that we have here on Earth. Mars also has less gravity than Earth and a thin atmosphere. Mars' landscape looks like a desolate and strange land full with reddish soil, rocks, dunes, and dust. The surface is composed with tholeiitic basalt, which is a type of rock produced by submarine volcanism. It also has minerals that contain silicon and oxygen, metals, and elements that are found in rocks. Most of the rocks, like tholeiitic basalt, appear to be originated due to the volcanic activity that occurred on the planet. Apparently, the planet is completely red, but its colors are more varied than that. If we look carefully, we can see that Mars has brown, gold, white, and bronze colors. Then why does it appear as red? Well, it has to do with the oxidation of the iron that the rocks, the soil, and dust of Mars have. The dust is lifted up to the atmosphere with the help of air and dust devils. So, from a distant place, the planet looks red. Now that we've touched the topic of wind, it's worth mentioning that Mars winds have been one of the factors that have changed the Martian landscape. The surface winds are about 16 to 32 kilometers per hour. There are some dust storms that can happen at a global scale. For example, in 2001, distinct large storms rose air to high levels of the atmosphere and the whole planet was covered. This lasted for months. There are also dust devils that change the landscape. Dust devils are Martian winds that are like swirling columns of wind and dust and have a height of approximately 8 kilometers. Earth has dust devils too, but they are not as big as these ones. Dust devils remove dust from the surface and create unique patterns, exposing a darker material below the dust, as we can see on the screen. Dust devils also create large dunes in the surface by taking material, commonly soil from canyons, and then the material is released in the fields. After this, the soil becomes hardened and stationary. In addition, the temperature and weather changes drastically. Viking 1 and 2 were the ones to record the temperature. In summer, Viking 1 recorded that the maximum was of minus 33 degrees Celsius and the minimum was of minus 83 degrees Celsius. And Viking 2 measured that the lowest air temperature was of minus 100 degrees Celsius. The Mars Global Surveyor was capable of mapping the whole planet with a laser that measured the altitude of each region. This is how we realized that Mars has low and high surfaces, and we could have maps like this one. Thanks to this map, we can see that most of the southern part of the planet has high and mountainous terrain, and the northern part of the planet has a lowland terrain. In this map, we can see some of the most important places of Mars, like the Utopia Basin, the Hellas Basin, the Tharsis Rise, or the Chryse Planitia. The highest place in Mars is a huge volcano called Olympus Mons, and the lowest place is a basin called Hellas. Scientists believe that in the past, Mars had water in its surface for two main reasons. The first reason is that Mars has valley networks, deltas, channels, and lake beds, and the second reason is that there are rocks that could have only formed if there was liquid water. Moreover, there are three types of channels: outflow channels, valley networks, and gullies. Outflow channels run for thousands of kilometers. Their depth is about 1 kilometer and their width can reach up to the hundreds. The largest is Casey Valles. Inside these channels there are little islands, terraces, score sections, and waterfalls or cataracts. Valley networks are similar to the river valleys on Earth. They are smaller than outflow channels and their organization is what identifies them. They are like branches, small tributaries or affluents that are grouped at higher elevations, and when they reach lower elevations they form larger tributaries. They continue merging until they became a stream. Gullies are formed on steep slopes like the walls of craters, and on the top they have an alcove that little by little narrows down into channels as it descends. At the end, they merge with the surface, giving the shape of a triangle. In addition, it is believed that about 3.5 billion years ago, the surface of Mars experienced massive floods on the lowlands. As a fun fact, I found that NASA has an animation of how Mars would look if it had water like Earth. And as you can see, most of the ocean would be on the lowland terrains, which are mostly on the north part of the planet. Nowadays, water can be found as ice in the polar regions. Just like Earth, Mars has polar regions in its north and south poles, but the polar regions in Mars are a combination of water ice and carbon dioxide ice. Planimborium is the name of the north polar ice cap of Mars. It has a diameter of 1,000 kilometers and it's made out of 4 layers. A basalt unit at the bottom made of sand and dust cemented by water ice. Above it, there are polar layer deposits which are composed of mixed layers of atmospheric dust and water ice. Then we have the residual ice cap made of pure water ice with a volume smaller than the volume of Greenland's ice cap. And on top of that, we have the seasonal ice cap made of CO2 ice that forms and disappears every year. Also, the North Polar Cap has a concentration of sand dunes mixed with the ice. The southern ice cap is above a crater surface that covers part of a basin called Prometheus. Its lower layer is called Dorsa Artegea Formation, made of ridges of sand and gravel, and it spreads farther beyond the edge of the ice cap. Above, we find the polar layer deposits made of water ice with dust, and the layer is thicker than its counterpart up north. The residual ice cap is composed of water ice and a thin layer of ice CO2, and it erodes into the Swiss cheese features, as scientists call them. At the top, the seasonal ice cap made of iced CO2 is found, and due to temperature changes, pressurized CO2 gas is trapped under the ice. As the sun hits the surface, the ice melts in weak spots and the gas erupts out of the spots, creating geysers. Also, in the past, heat from the interior produced tectonic forces that push and pull the crust. These movements created long, narrow throats called graben by places of the surface pulling apart, and long, narrow, twisted features called wrinkled ridges by places of the surface pushing together. Furthermore, the planet does not have a magnetic field, but it was discovered that there are some places and rocks of the planet's surface that have been magnetized. This means that Mars could have had a magnetic field in the past and that its core has cooled and solidified. Most of the rocks that have evidence of a long-gone magnetic field are found in the southern highlands. Moreover, the surface of Mars has craters, basins, canyons, and volcanoes all around the entire planet. If you go to Mars, craters are the most common geologic feature that you will find in your way. You'll see them in almost any size. There are 4 types: simple craters, complex craters, peak ring craters, and multi-ring basins. Simple craters are created by the impact of a solid object. They are less than 8 kilometers wide. They have the form of a ball with low rims and are surrounded of a layer of debris called ejecta. Complex craters are created when an object is larger or faster or both. They are shallower than simple craters. The center of their cavity rises after the blast. They generate more impact melted rock that covers the crater's floor. The inner walls can fall downward, and the ejecta has bumps and shows shows that there was outward flow from the crater. Scientists consider a crater being part of the peak ring craters family when it has a diameter between 100 to 150 kilometers. They have a ring of peaks in the crater center due to the merging of the center rising and the collapse of the walls. This ring becomes eroded and leaves the ring incomplete. The last category is the multi-ring basins. These are craters with large diameters going from hundreds to thousands of kilometers. Obviously, the big and large basins on the surface were created when asteroids collided with Mars. The Hellas Basin is the largest basin and has a length of 2,300 kilometers and a depth of 9 kilometers. And the Utopia Planitia and Isidis Planitia are remnants of other large ancient basins. The canyons of Mars are also large. Scientists believe that canyons were formed by geologic faulting on a huge scale, and as a result, pieces of the crust sank between faults on both sides. They don't know what caused this geologic faulting, but they speculate that it was a consequence of the intense volcanic activity. The Martian canyon system is called Valles Marineris, also known as Mariner Valley, and is the largest one with more than 4,800 kilometers. So if we moved and placed this canyon on Earth, it would cover more than the United States. At its deepest, it has 7 kilometers, and at its widest, it has 320 kilometers. Valles Marineris has about 10 times the size of the Grand Canyon in the USA. It is worth mentioning that Valles Marineris has an extension at the west called Noctis Labyrinthus, also known as the Labyrinth of Night. The valleys go from the Tharsis Bulge to the east of the planet, and the canyon is divided in 3 sections. Section 1, found at the west of Noctis Labyrinthus, there we can find closed canyons and depressions. Section 2, at the east of Noctis, the depressions begin to be wider and deeper and are more continuous until they join to form the east-west canyons of Valles Marineris. Section 3, at the east of Valles Marineris, where the canyons are shallower and then the canyon system disappears into tumultuous terrain. Finally, let's talk about volcanoes. Mars volcanoes are no longer active, but they are really huge. They were the result of the movement of the inner structure of the planet. These volcanoes produce 2 main features, shield volcanoes and flood basalts. Shield volcanoes have the shape of a shield. They are wider and created by many flows of lava. Olympus Mons is a perfect sample. Flood basalts are sheets of lava that cover all their surfaces like concrete. Other features are lava flows, lava channels, patera, and rootless cones. Lava flows are outflows of molten basaltic rock from a volcano that had a non-explosive eruption, and they travel downward from the surface. Lava channels are stream-like channels that were carved by flows of molten rocks. Patera are low-profile volcanic vents found in the southern highlands near to the Hellas Basin, and it is believed that they are the remains of volcanoes that erupted after the Hellas Basin impacted. Rootless cones are small cinder cones that were created after lava flows came into contact with water or ice. There is a part of the planet called the Tharsis Bulge where the most intense and recently active volcanic region of the planet is located. Of course, there are more volcanoes in other parts of the planet, but the Tharsis Bulge is the largest place for the volcanic activity. In the Tharsis Bulge, we can find Olympus Mons, the largest volcano in Mars and in the solar system, with an altitude of almost 27 kilometers, more than twice the height of Mount Everest, and a diameter of 600 kilometers. Along with Olympus Mons, there are other 3 large aligned volcanoes, Arsia, Pavonis, and Ascreus Mons, and other smaller volcanoes. In addition, there are other volcanic centers besides Tharsis. There exists Elysium, Syrtis Major, and other smaller clusters. Scientists look if volcanoes have craters of asteroids that could have happened billions of years ago. But Olympus Mons barely has any impact craters, so this means that it is much younger and the lava would have flown thousands or millions of years ago, but this would be a relatively short period of time that has passed. So volcanic activity on Mars has stopped, hasn't it? Well, scientists don't know for sure if all the volcanic activity has ceased completely, but NASA's InSight will examine the inner structure of the planet and soon we'll know. Generally speaking, Mars is the most appealing and entertaining planet in the solar system due to the composition of the surface, full with rocky reddish material, volcanoes, basins, canyons, and high and low terrain. We've arrived to the end of this journey through Mars geology. I hope you enjoyed the video. I really enjoy reading about it and investigating about it. So I'll see you the next time.